What is a sequence? A sequence is basically a list of numbers. So we have two examples of sequences here. One way that we can think about a sequence also is that it's basically a function where you're inputting only integers. Here's an example of a sequence defined explicitly using a formula. Each of these places here represents a position. In the first place, we're going to say that n, which is the position, is 1 because it's the first place. In the second place, n is 2. In the third place, we're going to say n is 3 for our equation. And in the fourth place, n is 4. And guess what? N is equal to 5 in the fifth position. So we're basically going to plug these numbers in as our n value to figure out what number goes in that spot. So in the first spot, n is 1. So we're going to say plug in 1 or substitute 1 for all the n's. So we're going to say a sub 1, which is the first number, is going to be 1 plus 2 over 1. If we add this all together, we're going to end up with 3 over 1, which is just 3. Now, for the second position, well, we're going to plug in n is 2. So put 2 for all the n's. So in other words, a sub 2 is equal to 2 plus 2 over 2. So if we work this out, 2 plus 2 is 4, divided by 2 is just going to be 2. So now n is 3, that's the third position. Substitute 3 for all the n's. So a sub 3 is going to equal 3 plus 2 over 3. And if we work this out, 3 plus 2 is 5. And we still have 3 for the denominator. So we have 5/3 in that place. Now for these two, n is 4. Let me just erase this here for a second. All right, so we know that n is 4 right here, so we're going to substitute 4 for all the n values. So we're going to say a sub 4 is equal to 4 plus 2 over our n value, which is not 2. Let me fix that. Should be 4 here. So 4 plus 2 is 6. And we're putting that over 4. So we're going to say that our fourth position is going to be 6/4. We can simplify this to write 3/2. So now let's do our fifth position. So we're going to first, let's go ahead and erase this. For the fifth position, n is 5. So we're going to substitute 5 for all the n's. So a sub 5 is equal to 5 plus 2 over 5. The 5 plus 2, that's just 7. And we have 5 for the denominator. So these are the terms of our explicit sequence. When we have a sequence, they're going to come in two types, either an arithmetic sequence or a geometric sequence. So an arithmetic sequence is basically something where we're adding the same amount each time. So in this case, we're adding the same amount to get to the next value. For this particular arithmetic sequence, it's going to differ from a geometric sequence. A geometric sequence, we're multiplying to get to the next value. So in this case, we're multiplying by the same number to get to the next number over. And that happens for all of our geometric sequences. So for this particular arithmetic sequence, a sub 1, remember, is going to be the first term. So a sub 1 is going to be 1 in this case. and a sub 1 is 2 in this case. So what about this D? What does that stand for? D is the common difference, and that's how much we're adding each time. So remember, we're adding 3 to go from 1 to 4. We're adding 3 to go from 4 to 7. We're adding 3 to go from 7 to 10. We're adding 3 to go from 10 to 13. So the common difference here is 3. So we're going to use all this to write out what our sequence would end up being here. So we're going to say a sub n. We're always going to write a sub n when we write explicit sequences, equals, and the first term here we said was 1. So 1 plus the D value we said was 3. Our common difference was 3. Remember, that was what we're adding each time. And we're going to keep this n minus 1. So always keep that n minus 1. So this is basically our sequence here. But we can also write this another way. It might also be written with that a sub 1 term at the back. So this is what it would look like. A sub n is equal to, remember our common difference was 3, times n minus 1 plus our a sub 1, which was 1. So this is just a second way that we can write that same arithmetic sequence in terms of a formula. In this case, our geometric sequence, we're going from 2 to 6 by multiplying by 3. We're going from 6 to 18 by multiplying by 3. We're going from 18 to 54 by multiplying by 3. We're going from 54 to 162 by multiplying by 3. So that means that 3 is what we're going to call our common ratio, which is R. We're going to substitute this and write out our formula. So we're going to say a sub 1 is our first term, which is 2. R, we said, was the common ratio, which we just found out was 3. And we're going to keep this n minus 1 as a power or exponent. So this is basically what our sequence is going to look like.